Crop growth. Soil nutrients are taken up by crop roots in the form of ions, NO3-, NH4+, Ca2+, and H2PO4-. Crop roots often take up more cations than anions. But crops must maintain a neutral charge in their roots for normal physiological processes to take place. H+ ions are released by root crops to compensate for the extra positive charges resulting to acid soils. Use of fertilizers. Some fertilizers such as ammonium, NH4+, fertilizers undergo nitrification process to form nitrate, NO3-, and during this process, H+ ions are released leading to acid soils. Acid rain. Oxides of sulfur and nitrogen are released into the atmosphere when burning fossil fuels. Released oxides react with rainwater in the atmosphere to form tetraoxosulfate, Fi, acid and trioxonitrate, V, acid. Oxidative weathering. Sulfides and other compounds containing Fe2+ produced acidity during oxidation process. Soil alkalinity. Soil alkalinity increases with weathering of silicate, aluminosilicate and carbonate mineral compounds that contain Na+, Ca+, Mg2+, and K+. The four listed minerals are usually added to the soil by the deposition of eroded sediments by water or wind. Soil alkalinity can also be increased by addition of water containing dissolved bicarbonates, especially when irrigating with high bicarbonate water. Insufficient water flowing to leach soluble salts can lead to accumulation of alkalinity in a soil. This is common in arid areas or poor internal soil water drainage situations, where the water that comes in is either transpired by crops or evaporates rather than flowing through the soil. Both acid and alkaline soils have influence on crop growth and development. For instance, agricultural crops grown in acid soils may experience some stresses such as AI, H&Mn toxicity as well as Ca and Mg nutrient deficiencies. Aluminum toxicity, which is the most widely spread problem of acid soils, occurs when aluminum is present in ionic Al3+ form. Aluminum ion Al3+ is the most soluble of all forms of aluminum at soil pH less than 5.0, acidic condition. Aluminum is not a plant nutrient but an ionic form of Al3+ that enters crop roots passively through the process of osmosis. Aluminum inhibits root growth and development by interfering uptake and transport of essential nutrients, cell division, cell wall formation and enzyme activity. However, strong alkaline soils, sodic soils, are characterized with slow infiltration, reduced hydraulic conductivity and poor soil water retention capacity that make crops to experience water stress. Generally, agricultural crops are varied in terms of suitability for soil pH range. Some crops can be intolerant of a particular soil pH due to a particular mechanism. For instance, soil pH 5.5 is not suitable for soybean plants when molybdenum is low in the soil, but the same pH 5.5 becomes optimum for soybean when molybdenum is sufficient in the soil. Most agricultural crops perform optimally around soil pH 7.0, neutral. This shows that it is very important to bring both acidic and alkaline soils to neutral soil pH value for optimum performance of crops.